Today's session is about chord of the ellipse. Now, as we have discussed chord to be the line segment which cuts the circle, as we have seen the chord of the circle is the similar definition which you're going to see for ellipse. So let's define the chord of the ellipse. For example, I take the ellipse x-axis, y-axis and origin. Then the chord of the ellipse is the line joining any 2 points of the ellipse. Say for example, if there's a line which cuts the ellipse in this manner, then clearly this line L cuts the ellipse at A and B. Therefore, AB is called the chord of the ellipse. So a line segment joining 2 points of the ellipse is called the chord. So this is referred as the chord. Is the chord of the ellipse. So we have infinitely many chords which exist in the ellipse. You have a chord passing here, a chord passing here, a chord out here, and here. So there are infinitely many chords which exist inside the ellipse because there are infinitely many points on the ellipse. There exists infinitely many chords for ellipse. Is how we conclude the chord of the ellipse is the line joining any 2 points on the ellipse. The line segment in the ellipse here being AB is the chord, for example. The next is the focal chord. So what is a focal chord? As you have seen that chord is part of the ellipse, the line segment joining any 2 points of the ellipse. That line segment, if it passes through one of the focus or foci, is called focal chord because the word focal itself refers to the line passing or the chord passing through the focus. Now, as we have 2 focus for the ellipse, say as we have 2 foci S and S dash for the ellipse, so a line segment a chord which passes through either S or S dash is called a focal chord. So for example, if I have a line segment which is passing through this, and there's another line segment which is passing through this, say this one, and there's another line segment which is not passing through the focus. Now in these cases I say that AB, which is passing through S, the focus S, is called the focal chord. Now similarly, as I see the line segment PQ which passes through the other focus S dash is also the focal chord. But the line segment LM which doesn't pass through either S or S dash is not a focal chord, but it is just called the chord. So this is how I differentiate between the chord and the focal chord. The focal chord refers to the chord passing through focus, and a chord refers to any line segment which passes through the ellipse. And of course, this can also be called as chord because a focal chord itself has the word chord. So AB, PQ and LM are chords and AB and PQ are focal chords. So this is how we identify the difference between the chord and the focal chord, as can be seen with this example out here. Next, about latus rectum of the ellipse. Now, latus rectum is a focal chord which is perpendicular to major axis of the ellipse. So, for example, I have the ellipse with focus S, with foci S and S dash, then latus rectum is a focal chord which is perpendicular to the major axis. This being the major axis and this being the minor axis, LL dash is a latus rectum because it is a chord passing through focus, that is the focal chord, and which is perpendicular to the major axis. LL dash passes through focus S and LL dash is perpendicular to X dash, which is the major axis. And this is the minor axis, is how we identify. Therefore, LL dash is latus rectum. This is how we define the latus rectum, which is a focal chord which passes through focus and which is perpendicular to major axis. So this is the condition which makes the focal chord to be latus rectum. So there are two focal chords, there are two latus rectums for ellipse. One is LL dash and the other is, you can say, M dash. So there exist two focal latus rectums for the ellipse which are perpendicular. One is LL dash and one is M dash. Is how we understand the latus rectums for the ellipse. And the plural for latus rectum is latera recta. That is, there are two latera recta for the ellipse, or two latera recta for the ellipse, LL dash and M dash. Now let's see the learning outcome of the three topics which are taken, that is the chord, the focal chord and the latus rectum. As we have three things, one is the chord, the next is the focal chord, and thirdly it is latus rectum. We identify that there are infinitely many number that is, for an ellipse there are infinitely many chords which I can draw. As you can clearly see that an ellipse has infinitely many chords which I can draw out here. So each of them is a chord as part of the line cuts the ellipse at two distinct points. Now as I see the focal chord, also there are infinitely many. Because even in this case, if I take the ellipse and I have the focus S and S dash, there are infinitely many lines which I can draw through S, and there are infinitely many lines which I can draw through S dash, as can be clearly seen from here. So chords, there are infinitely many, and focal chords, there are infinitely many. But when it comes to latus rectum, we have already seen that as I see this, there's only one line which is perpendicular and passing through focus, and therefore these two, there are two latera recta, infinitely many focal chords and infinitely many chords, is how we make the learning outcome of each of the chord, focal chord and latus rectum in number. Length of latus rectum. So now that we have discussed about latus rectum, let's see what is its length in its mathematical formula. So let's draw the lattice rectum for the ellipse. This, where I have x-axis, y-axis in this way. Now let me take one of the lattice rectum which passes through the focus S, which are given by coordinates a, 0. So we know that the lattice rectum is a chord passing through the focus and perpendicular to the major axis. So clearly LL dash is the lattice rectum. So with this lattice rectum, let me find the coordinates of A, L. So coordinates of L are given by AE, B square by A and AE, minus B square by A, and this is the length of the lattice rectum. So LL dash is said to be length of lattice rectum. So this length of lattice rectum is given by LL dash equal to 2b square by A units, is how we identify the length of lattice rectum is 2b square by A units. And the endpoints L will be AE B square by A and L dash will be AE minus B square by A, which are called the extremities of the lattice rectum, which are called the extremities of lattice rectum. So L and L dash are the extremities, with L given by A, B square by A and L dash given by A, minus B square by A, and the length of lattice rectum LL dash is 2b square by A units. This distance being 2b square by A units. That's how we identify the length of lattice rectum. Now, since there are two lateral recta, one of the lattice rectum being LL dash, the other lattice rectum would be here with S dash being minus AE, 0. Therefore, if I join this and if this is perpendicular to the major axis, then the lattice rectum MM dash is called the other lattice rectum on the negative side of x-axis. So the length of the other lattice rectum is also 2b square by A units, is what we identify. The length of both the lattice rectums are equal, and this will be equal to this, and each of them are with value 2b square by A units. And the extremities endpoint M is given by minus AE, B square by A, and M dash is given by minus AE minus B square by A, because M and M dash lie on the negative side of x-axis, both will be minus. Is how we identify the other lattice rectum with the length and endpoints. Lengths are same, the endpoints change. So therefore there are four extremities LL dash, MM dash, and two lengths of the lateral recta, this and this, which are equal. Is how we understand the concept of lateral recta connected with the lengths and extremities of through the ellipse. Now let's see the equation of lattice rectum. As we have seen the length, now comes what would be the equation of the lattice rectum. Now since there are two lateral recta, we have two equations which we need to identify in case of this topic. So in this case, I have an ellipse X and Y which is an ellipse. and we have the lattice rectum through A0 and another lattice rectum through minus AE. Is how we get the two lattice rectum. Now in this case, we need to find equation of this lattice rectum and equation of this lattice rectum dash also. Now as I clearly see here, this is a line which is parallel to y-axis and at a distance of AE units from origin. Therefore, this is a line being parallel to y-axis. Equation of lattice rectum is x equals AE, and equation of this lattice rectum is x equals minus AE. So are the two lattice rectums or the two lateral recta which we see, one of the equation is x equal to AE and x equal to minus AE. So equation of LL dash is x equal to AE, and equation of dash is x equals minus AE, as we can see here, this and this. Equations of the two lateral recta LL dash and dash are x equal to AE and x equal to minus AE. Now let's see the equation of lattice rectum if A is less than B. That is, if I have an ellipse x squared by A squared plus y squared by B squared equal to 1 with A less than B, then with this condition we have the ellipse in the shape like this. X, Y is what we get. Now because A is less than B, we have the ellipse with major axis on y-axis and minor axis on x-axis. Therefore the focus shifts to y-axis as S and S dash. And the coordinates of S are 0 BE, and this is 0 minus BE. Therefore, the lateral recta passing through focus S would shift in this manner with L and L dash, and this lateral recta would shift with M and M dash is what we get. And therefore, equation of LL dash would be, this is a line which is parallel to x-axis. Therefore, if I draw a line parallel to x-axis and at a distance of BE units from origin, then clearly I have this line to be y equals BE. And this, with equation of MM dash, which is a line parallel to x-axis but below origin with the distance being BE, will be on the negative side of y-axis, and hence I have this to be y equals minus BE. So equation of MM dash is y equals minus BE is how we identify the equations of lateral recta LL dash and MM dash in this case. Now next comes the length of lattice rectum for A less than B. So let's take even the length of lattice rectum which we need to identify for this topic. Now let's see the length of lattice rectum for A less than B. Now as I've seen that the lattice rectum, the lateral recta are LL dash and MM dash, the endpoints of the lateral recta are given by L, which is 0 BE, A square by B, comma BE, and L dash given by minus A square by B, comma BE. And for M, it is minus A square by B, comma minus BE, or this is plus A square by B minus BE, and this is minus A square by B and minus BE. Is how we get all the four end extremities of the lateral recta for A less than B. So I have my L given by A square by B and BE, and L dash, which is minus A square by B and BE, which are the extremities of the first latus rectum L dash. And the other extremities are M, which is A square by B minus BE, because it comes in the negative side of y-axis below origin, and M dash is minus A square by B minus BE. Is how we identify the two sets of extremities LL dash and MM dash. And coming to the length of latus rectum, my length of latus rectum, which is given by LL dash, also given by MM dash, because both are equal, is given by the formula 2A square by B. Is how we identify, as can be clearly seen here, that this distance is A square by B and this distance also is A square by B. So A square by B plus A square by B is 2A square by B, which is LL dash, and hence the length of latus rectum LL dash or MM dash, because these two are equal, is 2A square by B units. Is how we identify the length of latus rectum for the ellipse with A less than B. Now let's take the standard equation of ellipse with A greater than B and see what would be the relation between the foci S and S dash and the length of major axis. They are very much related through the point on the ellipse, which we're going to see in today's session. So coming to this, the standard equation of ellipse being x square by A square plus y square by B square equal to 1. So this being the standard equation of ellipse, x square by A square plus y square by B square equal to 1 with A greater than B. Now here, let's see the relation between the foci and the major axis. So for example, I have the focus S and the other focus S dash, and P be any point on the ellipse, say P. Now if S and SI are foci and P is any point on the ellipse, then we know that this is the major axis and this is the minor axis. Is how we identify the major and minor axis. Now let me join P with S, that is SP, and the other focus joined here with this. So joining SP and S dash, I get this to be like this. So joining S with P and S with S dash, I get the relation SP plus S dash P is always equal to T, 2A, that is a constant. Now this is a relation which we need to identify in case of the foci and the point, that you take any point on the ellipse. If S is joined with P and S dash is joined with P, SP plus S dash P will be equal to AA dash. That implies SP plus S dash P is equal to length of major axis. Is how we identify the length of major axis connected with S, S dash and P. SP plus S dash P is equal to 2A, which is this, the length of major axis.